This is a story about a galaxy-scale lens and the multiple secrets it reveals. By now, you've probably used contact lenses, a magnifying glass, or even a wine glass. They all have one thing in common with this cosmic lens called SDP-81. They all bend the light that goes through them. Using images taken with the Atacama Large Millimeter Submillimeter Array, or ALMA, Academia Sinica astronomers Kenneth Wong, Sherry Suyu, and Satoki Matsushita have analyzed the highest ever resolution images of a gravitational lens. The lensing effect can be used to calculate the mass of a supermassive black hole at the center of the foreground lensing galaxy. With the high resolution and sensitivity of ALMA, this type of measurement can be made for the first time with submillimeter wavelength observations. In this system, SDP-81, the light from this background galaxy is bent and forms a ring-like structure, a rare and beautiful phenomenon called an Einstein ring. Over 100 years ago, Albert Einstein predicted the bending of light by a massive body. The gravity of the massive foreground galaxy deflects the light from the background galaxy and creates the ring structure. The background galaxy contains a large amount of dust that has been heated by vigorous star formation, causing it to shine brightly in submillimeter light. ALMA is a submillimeter telescope which is ideal for observing dusty objects. But that's not the only new finding that has come out of SDP-81. All galaxies like the foreground galaxy of SDP-81 are thought to contain supermassive black holes at their centers. Lensing theory predicts that the brightness of the central image of a gravitational lens system is very sensitive to the mass of the supermassive black hole. The more massive the black hole, the fainter the central image. Because the central image of SDP-81 is extremely faint, it can be used to calculate the mass of the supermassive black hole at the center of the lensing galaxy. In this case, the inferred mass is over 300 million times the mass of the Sun.
All galaxies similar to SDP-81 seem to have supermassive black holes at their centers. They can be millions or even billions of times more massive than the Sun. However, we can only directly calculate the mass for very nearby galaxies.
ALMA opens a new frontier to weigh supermassive black holes at centers of lensing galaxies, which cannot be done previously using optical facilities.
With the high-resolution capability of ALMA, which we helped to realize in the last 5 years, now it is possible to perform the new science, which cannot be done with any other instrument.
Measuring the mass of more distant black holes is key to understanding their relationship with their host galaxies and how they grow over time.